Okay, good morning, Year 5-6. Welcome to your maths lesson for Tuesday, the 23rd of February. So arithmetic questions, start off with these again, 5 to 10 minutes, no more than that. Pause the video now. Okay, let's look at the answers. 243 times 0 is 0, anything times 0 is 0. 14 divided by 7 will be 2, because 2 times 7 is 14. 87 take away 21, we've got 66. 602 take away 574 will give you 28. Hopefully you didn't add those two numbers together, and if you did, you realised that a larger number in there wouldn't make any sense. 1,210 divided by 11, 110. 21.14 times 10, 211.4. 60 divided by 60, take away 50. So usually subtraction you would do kind of later on, but it's in brackets. So we are going to do it first. So you do 60 take away 50, which is 10, and then 60 divided by 10 would be 6, because 6 times 10 is 60. And then 5 cubed is 125. Now, we are thinking about area still. And before we go on to doing more area of a triangle, I just want to do a quick recap of finding area of a rectangle and make sure we're really comfortable with that. So with these questions, what we want to do is find the area of these rectangles here. So there's a couple of ways we can do it. We can count the squares, because we measure area in squared units. Or if we don't have the squares, we can think about how many squares there are in the rectangle by multiplying the width and the length of the rectangle. Because if we think about it, there are in this rectangle here, there are 1, 2, 3, 4, 5 squares in each row. So we'll say that's 5 centimeters along here. And then there is 1, 2, 3, 4 squares in each, 5 in each row, 4 in each column. And what that means is effectively, like we talked about before half term, that effectively gives us an array. So I can multiply 4 and 5 to tell me how many squares there are in total inside this shape. And remember, that area is the space that this shape covers. So 4 times 5 is 20 centimeters squared for the area of that rectangle. So pause the video now and calculate the area of these rectangles as a recap. Okay, so area of these rectangles, so you can either count the squares in this one, so we can see it's 6 centimeters squared, or you could have done 2 times 3. This one, it's not giving you the squares, but it's giving you the units that you could use to calculate. So we want to do the width times the length of it. 3 times 5 will be 15 centimeters squared, and 9 times 4 is 36 centimeters squared. So it's really important we are comfortable with calculating the area of a rectangle. And then we can move on and think about calculating the area of a triangle, because as we started to think about yesterday, we started to realize that actually calculating the area of a triangle can be done by turning it into a rectangle and then halving it, as long as that when you turned it into a rectangle, you effectively doubled the size of the triangle, because that's the only way, by halving it, you're going to be able to calculate the correct area. So if we look at these two triangles here, we were able to calculate the area by creating a rectangle which was effectively double the size of the triangle. So we drew our line up here and across here to turn this into a rectangle. Now, it wouldn't make sense if you carried the line on down here and then went up, because we need to create it as a double of this triangle here. So you're trying to create the rectangle, because what that meant was that you could multiply the length of the rectangle by the width of the rectangle. So in this case, the length of the rectangle, let's say, is 1, 2, 3, 4, 5, 6 centimeters. multiplied by the width or the height, 1, 2, 3, 4 centimeters. And what that would give us is the area of this rectangle. So by multiplying those two together, 6 times 4 is 24. Now that's the area of that whole rectangle. And what we then can see is that if we split the rectangle in half, we create two equal halves, two right-angled triangles, and then what effectively we're doing is halving the area of the rectangle. We're halving the area of the rectangle to give us just the area of half the rectangle, which is this triangle. This is half the rectangle, which is in this triangle here. So by doing that, we then get an area of 12 centimeters squared, because half of 24 centimeters squared is 12 centimeters squared. And then same with this one down here. We had a triangle. We extended it to make a rectangle. So we doubled the size of this triangle to make a rectangle. Remember, a rectangle will need to have 4 right angles. And then we calculated the area of the rectangle. So it's 3 here across here, 2 across here, and that gives me, multiply those together, and that gives me the area of this rectangle. You can see by counting the squares, 1, 2, 3, 4, 5, 6 is the area of this rectangle here. But what do we want? We want the area of half of that rectangle, which effectively is this triangle here. It's also this triangle down here as well. We want the area of this triangle. So half of 6 is 3, and that gives us an area of 3 centimeters squared. So what does this mean in terms of coming up with a calculation? So what we're starting to move on to now is thinking of that rectangle, and actually what that means is in a calculation to be able to work out any triangle that we come across and calculate its area. And we can then effectively start to skip that step of drawing a rectangle. That's what we're building towards. So what are we doing as a calculation? Well, we're multiplying, if you look at this triangle here, we're multiplying the base of the triangle by the perpendicular height of the triangle. Now, if you think back to year 4, you would have learned that perpendicular means at a right angle. So you would have thought of perpendicular lines as meeting at a right angle. So the perpendicular height must meet at a right angle. So we're doing the base times the height, because if you think about it, with that rectangle that we would draw, the line would come across here, which would still be 4 across there, and the line would come up here, and this height over here would still be 7 as well. So that would be our rectangle, but we're going to skip that step. We're thinking of it without the rectangle now. We're thinking of it as the base multiplied by that height, which gives us the area as if it was a rectangle, but then without doing the rectangle, we immediately divide it by 2, because we know that if we did half that rectangle, we would then find the area of just this triangle. Okay, so we do the base times the height and then divide it by 2, because we're halving that rectangle to find the area of just this triangle. Another way of thinking about it is the area of the triangle is half multiplied by the base, because multiplying something by half is the same as dividing by 2. Half of the base, remember times is the same as of, half of the base times the perpendicular height. So another way we could think about it would be half of 4, which is 2, multiplied by 7. Remember, you've got to do 2 when we've got 2 multiplications to do. We do 2 of them first, then multiply the answer by the third one. So half of 4, which is 2, multiplied by 7 is 14. So would that work with this one up here? The base times the perpendicular height. 4 times by 7 is 28. Divide by 2 is 14. So there's 2 ways of thinking about it. But either way, we get to 14 centimeters squared. Now, the key thing here is really to think about what is the height and what is the base of the triangle. And that's often a step we forget to think about, and it's one we need to focus on today, because this 9 centimetre length here cannot be confused as the height, because that's going to lead to mistakes. So we need to be really careful when we think of the height. We mean the perpendicular height. We mean the height of the triangle from the base at a right angle, and that perpendicular means it has to be at a right angle. So that's really, really important. So that's what we're going to think about here. So do you agree with Tiny? Tiny is the tortoise. Tiny says the base is along the bottom and the perpendicular height is up the side. Do you agree with Tiny? Have a little think. Pause the video if you want to. Do you agree with what Tiny says? Okay, so if you think back to what I was just saying, it's not the case that the base is just along the bottom and the perpendicular height is up the side. The base can actually be any side. So you could make any side the base. However, with right angled triangles, you really want to make the base one of those sides up against the right angle, because the perpendicular height has to be from the base up the right angle. So this is, you could say this is the base, but is this the height? No, because it's not coming from the base at a right angle. So this is not the perpendicular height. So what you could say is that this was the base over here, and then this could be the perpendicular height, because it's coming from the base at a right angle. So it has to come from the base at a right angle. Now you could swap those around. So you could have the base here and then the height coming up here, because it would be coming from the base at a right angle. Now, when I say this could be the base, that would mean drawing the perpendicular height differently, and we'll be coming on to that tomorrow. So don't worry about that too much today. We're purely focusing really on right angled triangles and thinking about using that right angle to calculate where the base is and where the height is. So on these three triangles, we're thinking about where's the base, where's the height. So with this one, we're going to have the base here, and then the perpendicular height comes up from the base at a right angle, and these could be swapped over. And on this triangle, where's our right angle? Our right angle is here, so I'm going to put the base here, and then the perpendicular height coming up off that base at a right angle. And then this one, the base is at the bottom of the triangle, but that's not where necessarily the base goes. But here we've got the base at the bottom of the triangle because we've got the right angle here, so we can put the base here, and then the perpendicular height can come up off the right angle of the base. So how does that help us? Well, then once we can identify the base and we can identify the perpendicular height of the triangle, and we now know the calculation we can do to find the area of the triangle, assuming we have all that information, we are now able to calculate the area of a triangle without necessarily drawing that rectangle to help us, but we still can do if we want to. There's nothing wrong with that. So the area of the triangle is half times the base times the perpendicular height, or you can multiply the base and the height and divide it by 2. So let's think, what of these are the base and which one is the perpendicular height? So pause the video and think what you think is the base and the perpendicular height. Okay, so you could either have this line as the base or this line as the base, and then the other one would be the perpendicular height. So let's say this line is the base, and then this line up here is the perpendicular height. So we're going to do half times the base. So we're going to do half of 6, which is 3. So half of 6 equals 3. So half times the base, we get 3, and then multiplied by 12. Not a great colour, but there we go. So half times the base means half times 6, which is half of 6 is 3, multiplied by the perpendicular height, which is 12. 3 times 12 is 36. So the area is 36 centimeters squared. So you could do base times the height and then divide it by 2. So 12 times 6, 72. Divide that in half and you should still get 36. You'll get the same answer. Okay. Now see if you can work out the area of this triangle here. This one has got slightly more difficult for you because 2 of the lengths have been given in millimeters rather than centimeters. But if you divide it by 10, you convert it into centimeters. Okay, so pause the video and calculate the area of this triangle. Okay, so what you need to do, step 1, let's write them down. There we go. Step 1, identify the base. Step 2, by the perpendicular height. And step 3, do the calculation. So area of triangle equals half times the base times the perpendicular height. There we go. So hopefully we're going to go in those steps. So identify the base. Let's say that's the base because we're working at the right angle. Then we want to find the perpendicular height. Well, the perpendicular height has to come from the base, so it's going to be either that line or that line, but it needs to come from the base at a right angle. Here's the right angle, so it needs to come up from that line there. So there's our height. Then we need to complete the calculation. So we need to, before we do that, we need to make sure we're working in the same units, because if we're working in different units of measurement, then we're going to get stuck because we're multiplying millimeters and centimeters together and we'll get the wrong answer. So we're going to say that that is 5 centimeters and this is 10 centimeters. So important step we need to add in here for this question as well. So now we can work out half the base. So in this case, we've got half of 5, which is be 2.5 times 8. So actually, maybe in that case, maybe we want to multiply, we want to convert the 8 into millimeters if you wanted to, I suppose. But we'll do half the base times the height. So we'll do 2.5. 2.5 multiplied by 8. So what we'll do is we'll remove the decimal point, and then we'll remember to, so to remove the decimal point, we're effectively multiplying by 10, so we need to make sure we divide our answer by 10 at the end. So we'll do it multiplied by 8. So 5 times 8 is 40, and then 2 times 8 is 16, and then add the 4 will be 20. Then we need to divide our answer by 10, so our answer is going to be 20. So the area of this triangle will be 20 centimeters squared. Okay, so we did half the base, which was 2.5 centimeters, and multiplied that by the perpendicular height, which was 8 centimeters, and then 2.5 times 8 gave us 20. So we've got 20 centimeters squared. Okay, time for you to have a go now. So you want to, with these silver questions, calculate the areas of the right angled triangles. So what are the steps you need to follow? So the steps are the same. Let's copy them from the previous page. So the steps are the same. So you're going to identify the base, identify the perpendicular height, and then step 3, you are going to do your calculation, half the base times the perpendicular height. Let's move that up there slightly. Okay, so pause the video and have a go at trying to calculate the answers to these questions. Okay, let's move this out the way and have a look at our answers. So triangle A, we got 5 centimeters squared. triangle B was 8 centimeters squared, and triangle C 10 centimeters squared. So if we just look at one of them, so let's look at this one here. So step 1, identify the base. Let's say that's the base there. And then step 2, we want to identify the height, perpendicular height, right angle up from there. And then how long are those? So 1, 2, 3, 4, 5. And then this is 1, 2 centimeters. And then we've got another 2.5. So if this is 5 centimeters long, it's half the base, which will be 2.5 times 2. So 2 lots of 2.5, double it effectively, and you have 5 centimeters there for that one. And then hopefully you got the other ones as well. So with these ones, half times 6, if this was your base, times by 8, the perpendicular height, to give you 24 centimeters squared. Maybe you decide to switch those around, so you did 4 times 6 instead. But 4 times 6 is still going to give you the same answer. This one, half the base, so 8 millimeters times by 15, perpendicular height, to give you 60. Again, you might have chosen different to be your base and your height, which is fine. You'll still get the same answer. And then this one, 12, half times 12, which will be 6, multiplied by 5, gives you 30. 6 times 5 is 30. Okay, moving on to the goal questions. So you need to calculate the area of these triangles. And we've got a question for you to think about here. Annie's calculating the area of a right angled triangle. And she says, I only need to know the length of any 2 sides to calculate the area of a triangle. Do you agree with Annie? Explain your answer. And then we've got an area, and what could the length and the height of the triangle be? What different possibilities could you come up with? So it's a little bit more open-ended for you to think about there. So pause the video and have a go at these questions. Okay, so area of this one, 12 centimeters squared, and area of this one over here is 10 millimeters squared. And then, do you agree with Annie? Annie's incorrect. It's not sufficient to know any 2 sides. She needs the base and the perpendicular height. So it's really important that you know the specific sides. If by chance you were given those 2 sides, great, but it has to be the base and the perpendicular height that you know to be able to calculate the area. And then this one down here, what could the length and the height be? So possible answers, you could have had height of 18, base of 6, height of 27, base of 4, height of 12, base of 9. All of those would have created 54 centimeters squared area triangle. Okay, well done. And then platinum questions. So you're going to draw a triangle this time. Draw a triangle on the grid that has half the area of the shaded triangle. So draw let me say that again. Draw a rectangle on the grid that has half the area of the shaded triangle. Shows you importance of reading the question a couple of times to make sure you read it correctly. Draw a rectangle on the grid that has half the area of the shaded triangle. So have a go at that one and we'll talk about that one. And then the width of the right angle triangles is increasing by 1 centimeter. Investigate the pattern for the areas. What happens to the pattern if the length and the width increase? So what I'll be doing is just going to be interested to see some of your answers, and we can maybe talk about that on the Zoom at the end of the day for your answers for this one. So be interested to see what you come up with. So pause the video and have a go at these ones. Okay, so with this one, we want to draw a rectangle on the grid that has half the area of the shaded triangle. So what did you need to do? First, you needed to find the area of this triangle. So you needed to identify the base, which you probably would have used this as the base, multiplied it by the perpendicular height. So you multiply half the base, the base is 4, so half the base will be 2, multiply that by the perpendicular height, which would be 1, 2, 3, 4, 5, 6. So the area of the triangle would have been, so 2 times 6, 12, it doesn't say centimeters, but we know it's squared units, so we know the area. Let's say it's centimeters. So then you needed to draw a rectangle which had half the area of the shaded triangle. So you needed to draw a rectangle which had an area of 6 centimeters squared. And then, like I say, we'll have a look at and have a chat about some of the answers you come up for that one, or be able to have a look on Dojo. All right, well done, everyone. Really difficult new concept for us to get to grips with. We've got one more day of looking at it tomorrow as well. So I will see you then.